Yes, today we're going to cover the design of precast concrete parking structures looking at the system considerations with wind and earthquake forces. The objectives are to try to provide an understanding of the structural system design for precast and pre-stressed concrete parking structures. We'll look briefly at gravity load framing because it does have an impact on the vertical elements of the lateral force resisting system, and we'll also be looking at diaphragm considerations. I hope to provide an understanding of the use of shear walls in system design for the precast concrete parking garages. We'll look at configurations, some simplified stiffness analysis for load distribution, and discuss resistance to overturning. We're going to look also at wall diaphragm balance, look at an alternative approximate period calculation that may be useful in some applications, and discuss some wall structural modeling considerations. We're going to look briefly at moment resisting frames, discussing ordinary moment frames, special moment frames with precast concrete, and finally we will discuss diaphragms in precast parking garage structures. The basis of the loading condition that we use for structural design for garages, as with other building structures, is ASCE 7, the minimum design loads for building and other structures. For parking garages, our primary live load criteria is 40 pounds per square foot as a uniform live load, plus a requirement to sustain a 3,000 pound concentrated load anywhere in the floor of the structure. There is also impact loads which are required for barriers, but we won't get much into that in this part of the presentation on parking garages. We will discuss lateral loads, both from wind and earthquake loading. Low earthquake risk is considered seismic design category A and B. Seismic design category C is moderate risk, and seismic design category D, E, and F considered high risk and require special detailing considerations. Parking garage configurations provide some unique challenges that other building structures generally do not. And they have ramps in them. The ramps, you know, there's a requirement to determine how the ramps contribute to the weights at the levels that they span between in order to develop the lateral force resistance calculations. The ramps also break the layout of a parking garage into sub-diaphragms that have to be considered in design, and the ramps may create unintended load paths. Some would look at a ramp as an opportunity to make the structure act somewhat as a truss and actually assist in the bracing. That is an unintended load path because reinforced concrete braced frames are actually not a recognized system in the code, but also with the jointed construction that we have with precast, the demands that can develop across these across the joints probably don't make the use of the ramp as a framing brace feasible. But more importantly, there is the tendency to reduce the shear span in walls or columns along a ramp, which actually can accumulate or develop higher shear than might be anticipated without those restraints. So it certainly has an influence, something that needs to be considered in the course of design. Parking garages have stair and elevators, which again can be used for bracing, but they also will tend to provide remote stiffness in the structure. We'll talk a little bit about that when we discuss volume change. And parking garages usually have relatively long diaphragms, and that can create some challenges, particularly in seismic design conditions. important considerations in parking garages is to recognize that, different from a lot of other structures, and particularly monolithic concrete structures, is that behavior is controlled by jointing and by the connections that are made across the joints.